Okay, I just made something. Look at this. You can move around fully, and you can even stop, and it will face the direction. It took me so long to figure that out. You just walk, and then stop, and it's facing that direction. And then if we look at this NPC I made today, look at her. She's walking around randomly. Oh, I think she's. Oh no, there we go. And she can just stop. And she has the exact same thing where when you stop, it's facing the direction. There's a lot going on behind the scenes. If we look at this, you're facing idle currently, so it's currently moving. Hold up. So currently you're facing idle, and inside this, it's taking the last value that you moved. So let's say you're moved to the right, it's going to put the horizontal value to 1, and it will not reset it back to 0 when you're done moving. So then if it's still 1, you can then inside here get that it's 1 in the horizontal and make the corresponding animation, which is just the still image. And I thought of that all by myself. And then goes to movement, which I didn't think of all by myself. I followed a Brachy's tutorial. And if I were to move it I can't move this value because it's constantly being updated with code. But yeah, I can just set this to -1, and it starts facing that direction. And it faces downwards when it's. I'm quite proud of this. I'm very proud of this. And you can see when I start moving, it's setting it to -1 and 1, like that. And it's going to the corresponding walk animation. See, like, so it's currently playing right, left, right, up, down. I'm having a lot of fun with this. You can also go here, and oh yeah, you can't move that around currently. But if you look down at the preview, if I play it, look at this. I can just move it around, and if you look at the top, it's sliding between it. And if I go up, it's now facing up because it's closest to up. If I go down, it's now facing closest to downwards. If I go this way, it's facing to the left, and this way it's facing to the right. It is so much fun to play around with it. I mean, look at the bottom. Look at the sliders here. But yeah, it's coming along nicely. Oh, I also made the tree work. So when you can actually go under and over the tree. So if I were to drag this back over here, you can see you can actually go, you can collide with the trunk, you can go over it, and you can walk on the grass underneath it, but you can also go under it. Now there's a slight problem, like when you go right here, you're not completely under the tree, but it works, and that's great. I can also stand on the NPC. Because I made it so that the top of the NPC doesn't have a collision, so that when you walk like this, you won't collide with the tree trunk, because the top of your thing. Because in reality, this is just a 2D game. There's no shadows or anything like that. Also, I made it so the NPC couldn't go diagonally. And yes, I can literally just attach the NPC movement script to anything, such as the hero. Movement NPC. Remove the actual movement script. And if you look at that, it's going to, wait for it, start moving. Now, of course, it's looking weird because the thing is, it's moving at a speed of 2 when the normal is 5 with the animation. I made that one move at a speed of 1.25, and that's why the NPC walks so slow. And because it's the same script, it's going to have the exact thing, but because it's walking slower than 1, yeah. So I'm going to show you the script now. So if we look at here, this is the movement script. So we get the rigid body and the animator. And the first thing you do is we move, that's the first thing we do. We get the both of those, rigid body and the animator. So this basically adds physics to it, and this adds the animations to it, of course. Then we have move position every fixed update. So basically, update is called every frame, but if you have a, but if you want to, but if you very low frame rate, then it's going to be slow. It's not going to call that every fixed timer. So fixed update calls it every seconds or so. So it basically is more reliable on a timer rather than worrying about frames. So you handle physics in fixed update, which would be moving things. So we're going to move. So RB dot position is the position of the rigid body. So it's like the transform dot position, plus movement vector, which we'll look at that soon. Dot normalize. So that basically let's hover over them. Returns this vector with a magnitude of 1. So basically, what fixes here is if you go diagonally. If you didn't have the dot normalized, you would go faster diagonally. So it just fixes it. I'm not entirely sure what it does, but it fixes it. So multiplied by move speed. So it's multiplied by a factor of the move speed. So we're talking about that at the speed of like 2 or something. But the default is 5, as you can see, up where I'm setting the variables. Multiplied by time.fixed.time. Now, this is very confusing, but basically, it's the time since this function was last called. It's very confusing, but basically it speeds it up. Now, then we move on to the normal update, which is called once per frame, as you can see up here. So here we go. So movement vector is equal to new vector c. So input dot get access raw horizontal. So basically, whenever you press a horizontal key, so you move the joystick right on the controller. You click the arrow key, going to the right or left. You could do A or D. It's all going to get captured in this. Now, if you move to the right, it will set this value to 1. If you move to the left, it'll set this value to -1. And if you don't do anything, it sets the value to 0. Same with the vertical, just up and down. So then, we're going to set the animator. So you remember there's the variables horizontal and vertical, and if you set to 1, it starts facing to the right. Yeah, that's what this is here. That's what this is doing here. Now, so this is the hard part here, so that's just the walking animations here. The problem is we're not going to talk about speed because that's a bit more complicated. Sum it all up, the movement vector speed, so it has a value to tell you whether it's moving or not. And then if the speed is greater than 0.1, it'll go to the movements. So that's basically a condition to transfer over to the movement category where you start walking animation. It's complicated. So if movement vector, so this is the problem here, because you don't want it to, when you're facing and you just stop, you don't want it to reset to you looking downwards. You want to look where you just stopped. So it's harder, but I had to figure the system out on my own because the Brackeys tutorial didn't have this. But basically, you want to, I couldn't find any tutorial of this on YouTube, honestly. So basically what I did was I created 2 new floats, like horizontal and vertical. Okay, so we want it to only face the direction that we stopped. We don't want to always set it to the horizontal and movement vector value. I thought that was good, but then I realized that they reset back to 0, and so that it would be facing downwards again instead of where we want to face. So this is what I came up with. So when it's set to a value, so when you start moving, let's say you start moving to the right, it's going to set this to 1. So we're going to set a value called facing horizontal to 1, and we're going to make facing vertical set to 0. I don't know why, it's just... Oh, right. Because if we're moving to the right, we don't want to face to the... it doesn't know how to handle facing vertically. I think it just faces downwards. So we face vertical. That basically makes it so you don't go diagonally by accident. You can go diagonally in the game, but it messes up the facing. So basically it's making the facing not be messed up when you move diagonally. So when you face horizontal, it's going to set facing horizontal to 1. But notice how when I do this, if it's set to 0, it doesn't set the facing horizontal value to 0, even if movement vector is equal to 0. So that will make it so that it saves the last value but never saves the 0 value. So then it faces. That was annoying to find, but yeah. So next we're going to go to the movement NPC, and we're just going to compare it here. Okay, suddenly you realize there's a whole nother bit at the start. No new variables, just a whole nother bit. And the reason for this is if we collide with something that's not equal to the name hero, but I'm going to save that because it wasn't working there, that's not equal to the name here, so you just hit the wall or a tree, then it's going to do... Then if you were moving to the right, so let me put you in a situation. You're an NPC and you just hit a wall and you were just moving to the right. So if you're moving to the right, then you want to move to the left now. So that's what this does. It sets movement vector to the left. So you start moving to the left. And so then if you were moving to the left and you hit a wall, it's set to the right. And up and down, and they're the exact same thing. It doesn't allow you to go diagonally no matter how hard you try it, because it's an NPC and it doesn't look right at all. So so it's going to, if movement vector, so it's going to have the exact same thing here, but we're going to not set it at the very start of update because we don't want it to, because when we set it, we don't set it to the input. We are going to set it to a random thing, and we don't want it changing direction every second because that looks so weird. Let me show you that. Hold up. You can imagine what it looks like, but you're never going to actually know what it looks like until you see it. Hold up. Let's head back to Unity now. I'm going to show you this. See, she's moving diagonally, first of all. Look at how she's just changing direction constantly. Oh yeah, I forgot we set it to the player as well, so movement will have no effect on the player either. See what it's doing? It's always changing. It's always going that way as well. So we're going to head back to this and we're going to get rid of that. So next, hold on, I just want to move this back here. So next thing is that it's going to set the float horizontal to the thing because it's calculated it at the very start. So first of all, it's going to start things to calculate the movement, and then it's going to set movement vector to a random value. So either left or up or anything like that. Next, it's going to set horizontal to that value. So it's going to go, so let's say this is set to -1, this is set to 0. So that would be, oh, hold up. Alright, there we go. Now it rounds it every time. But, so it's going to start quarantine, calculate movement. Now we're going to go down here, and it's going to wait for seconds. So the reason we're starting a quarantine, and we can't just put it in update, is because it's waiting for seconds. And if you remember, update gets called every frame. But you're like, well, if it's start, can you just wait then? And unfortunately, there is literally no function to wait for seconds in start or update or anywhere, not even in C#. So you have to do a quarantine IEnumerator, and you do yield return new wait for seconds thing. And remember, it only started this at the start, so it's not starting this every frame or whatever. And it's going to run it, it's going to go, let's say it's going to 2. So it's going to wait for 2 seconds. So 1, 2, and then it changes direction to a random direction. And then the quarantine is going to run again because it starts the exact same thing again. So that's looping always, but there's always going to be a delay because of this line. Instead of putting an update, which we saw what happens when you do that. Anyway, so, yeah. Yeah, so then you just move towards the direction, and it does the exact same thing. And to make it not move diagonally is if the x is equal to 1, then it sets the y to 0. If it's equal to -1, sets the y to 0, x to 0, x to 0. And it just basically doesn't allow both values to be equal to something at any time together. So yeah, there you go. That's what I've been doing right now. And yeah, I'm going to video edit this now and then look on the dialogue. After that, I cleaned up the way you can interact with the NPC. Now you can actually go behind her rather than going on top of her. I just had to fix the order in there. She can still push you though. I'll fix that later enough. Yeah, she'll just stop when you can't, yeah. And also I fixed there being white squares at the side. I'm trying to show that there used to be white squares at the side, but then I can't find the squares in this video, but yeah, anyway, so I fixed the white squares at the side, and yeah, I'm going to put up the project on itch.io. I'll put the link in the description, and now a tutorial is going to pop up to show you how to download it. I will be showing Windows tutorial as well, but first it's Mac. Okay, so we're starting off by clicking download for the Mac, and we download it, and I'm just going to speed this up for you right now. Oh, flashbacks from Doors. So the next thing we're going to do is we're going to open the folder up, and then we're just going to double click the application. Now, unless you have a pretty old Mac, this does work on Apple Silicon. You can see I just fixed a privacy thing there. You have to do that, what I just did there. But yeah, when you open it up, you can just play around, and yeah. Now, it works on Apple Silicon too, hopefully. That's what Unity says it should. And yeah, so that should be it. And then to close it on Mac, you can just press F3 and then close the application. You'll see it soon here. Hold up, skip. Okay, so now we're gonna do the Windows tutorial. So you just click download, and it downloads it there. Now I can't open it up because obviously I'm on Mac. Hold up, we're just gonna skip forward. Okay, so then we open it up again, and inside here we have a bunch of stuff, and you want to double click the executable. And that's it for Windows, actually, because I can't show it because actually I double clicked it and it did nothing because Windows can't run on Mac. I tried to run it via crossover, like what I did with the Bendy Egg Machine video. It didn't actually work. So, yeah. So yeah, that was my new game. See you next time.